Hi, this is a video for the beginner with FreeCad. The FreeCad version we're going to use is version 017, release 13.541, which is the current version. Basically, the video is also valid for version 018. It is not valid for the older 016 version. Before we start, we switch to the gesture mode for the mouse. Be sure to do that the same, otherwise you might not be able to follow my mouse movements. So when you start to use FreeCad, the first thing is you need to switch to a workbench with which you're going to work. There is different possibilities. There is a part workbench where you work with primitives like cubes, like cylinders and so on, similar to programs that you can work on directly on the internet for tinkering your 3D parts and so on. But we're going to work with a more technical mode called the part design mode. We switch to the part design workbench, and the first thing is we have to create a new empty document. So what we're going to do, and every object in the part design workspace needs a so-called body. The body is the first thing we need to create. The body is the container for one solid. A solid is one piece of your whole design, of your whole machine, whatever it is, which is complete one part in itself. A body usually will be based on a sketch. The sketch is sort of a drawing which gives it the outline, how it should look in one direction. In a sketch, you first have to decide which plane you want to use. Mostly you're going to use the XY plane, which is, if you look from the top to the ground like a map, then you see the world from the XY plane, where X is east-west and Y is north-south, and the height is the Z-axis. You can also take another plane. If you would construct a house, you would probably start from the XZ plane and see Z pointing to upward in the drawing. But we're going to stay in the XY plane, which is mostly used for machine parts or something like that. In the XY sketcher, we can see several things. First, we see the symbols needed to create new geometry. We see the symbols needed to constrain the geometry we have in our drawing. We will use this later. We see a couple of other things we don't need actually, so we can move them freely on the screen to a place where they don't clutter the screen. And we have everything we need handy, which really is the drawing elements and the constraints. That's the most important things that you need in Sketcher. On the left side, in the so-called combo view, you see we have an empty sketch. We see the so-called solver messages, which are empty in the moment, and we see the constraints and we see the elements as they are being constructed. First, let's have a short look at edit controls. There you have a grid. You can switch the grid on and off on your liking. When you have the grid active, you may use grid snap, but it is not recommended unless your design is much easier to construct with a grid snap. Grid snap is not the best thing to do in constrained geometry. We see several problems with people who have used grid snap and therefore made mistakes later. What you can switch on and off is the so-called auto constraints, which means when you create a line, let's do that, and the line is going across the screen somewhere, there is no auto constraint. But in the moment I draw the line close to horizontally, at the bottom below the blue numbers you can see a vertical line, which means if I click now it will be a vertical line, and that is what we call an auto constraint. The same happens if I do this horizontally. We see the horizontal symbol and it makes an auto constraint, which we can see in the constraints list also. But let's stop this mode, and in using the gesture mode, which I forgot to switch, in the gesture mode and some other modes, it is the right mouse key, because if you continue you will make one line after the other. Right mouse click takes away this mode. Then, as usual in Windows, we can select all the stuff, and with the delete key we can delete it, because that's not what we need for the construction of the element that I want to create in this little tutorial. So all we do now is we close this window. I leave the grid on, but I don't use it actually. We leave it with this 3 windows on the left. You may, if you like, move this window, the combo view, but later on you will see there will be longer things written here, and it's not recommended to move it too much. Usually you will have more space on screen. This space is limited because I want to keep the video size on a relatively small level. So let's start with the actual construction. It is going to be a sort of a clamp, where I want to clamp something to an object. It's going to be something for a 3D print. And what I know is basically it's based on a rectangle shape. The size of the rectangle shape is known, which horizontally is going to be a length of 70 millimeters. Now it's bigger than on screen. We use the fit whole content to make it visible. The next thing that we need is the height. We know that the inner height should be 38.5 millimeters, and we want to have a wall thickness of 4 millimeters. Well, we could go and say we calculate this value, but we're going to do it a little bit differently. What I'm going to do is I will create an inner rectangle, and I'm going to give this inner rectangle a height. As I said, 38 0.5 millimeters. So we move this and we see this one is a little bit bigger, and what I'm doing is I'm going to fix this by telling this point to this point has a vertical distance of 4 millimeters, as well as this point to that point also has a vertical distance of 4 millimeters. And finally, at this stage, that was a mistake. First I have to switch to horizontal distance mode, clicking this, and I'm giving it 4 millimeters also. So let's go and move these values a little bit. What you should know is these values have nothing to do with the values you would have in a technical drawing. If you want to make a technical drawing later on from this, you will use the so-called TechDraw workbench, where you can move the values and the measurement lines in a more convenient way that is also looking better and more according to the usual drawing standards that you have in every country. Good. So the next thing is that we have to take away a couple of lines, which are these two lines. I select them and I take them away. So in this case, we now know this should be the same length as this minus the 4 millimeters, and we do this again using a constraint which is a vertical constraint of 2 points. Sorry, gotta click this both, and now it's constrained that these both are over each other. Next thing is I connect them with a line. There's two possibilities. One is you move your cursor to the approximate point that you can see on screen, but in the beginning you may probably fail with this. So better is draw a line so it is not auto constrained, and then say this point to that point is a coincident point. Say this point to that point is also coincident, and then the line closes this corner. So we're doing the same here. This time I'm doing it just in a different way, which is also put it somewhere. First, oh no, we're gonna do it differently. We're gonna switch to coincident constraining mode, which means now you can see the little dot, the red dot at the cursor, and for each subsequent 2 points that I'm clicking, it will automatically constrain them. We can do this the same with this constraint, which is a vertical constraint on the selected items. Click them and voila, it is vertical. So the next thing is we need to define the length of this leg, and the length of this leg is ruled by the length of the inner part, which is 40 millimeters. If you do these things with FreeCAD 0.18, you may have a couple of messages here telling about constraining problems and missing constraints and so on. So this is gonna look a little bit different than here in 0.17, but basically it's still the same method. So the next thing is, as we have defined more or less everything we know, we still can't move this, and it tells us it is an under constraint sketch with 2 degrees of freedom. Well, basically I could now say I don't mind where this is, but it's a good habit to define every sketch as fully constrained. So okay, what we're going to do is we're going to say this corner is on the origin point of our sketch, and now the sketch is fully constrained. We close it, we make it visible, and it's good to start saving it. And we call this one just clamp. So the next step is that we switch back to the model tree. In the combo box you have the tasks panel and you have the model tree. The model tree is the history of your design, which is going to be quite lengthy later on. Not in this design, but in your designs. Good. So first, from this 2-dimensional sketch, we're going to create a 3-dimensional object. There is a couple of possibilities. The one that you will use mostly in the beginning is a pad. A pad creates a 3-dimensional object from your sketch into one direction, which is in this case the z-axis. You can tell it how much, and for my design I need 15 millimeters. You could probably say I want to have that symmetric to the plane. Well, what is the plane? If we switch the origin visibility on, you can see that this is the plane on which we have constructed. Going back to this task, you can see by standard it goes into the positive z direction. Symmetric to plane would move it same distance both sides, and it could also be reversed, then it's just flipped to the opposite side of the XY plane. Okay, we leave it standard, going upwards 15 millimeters. Then we switch the view to a standard orthographic view. We don't use perspective view in this case because perspective view is more for things that are large in size, and if you see a building, then this may make sense. For these little parts we stay at orthographic view. We switch those origins off again, we don't need them. So once you have your first object, your first base feature, then you have different possibilities to work on it. When you start working, the first thing you can do is you can select the planes from the object you have, and you can go and say I want to draw something on this plane. Well, this works, but beware. Later on it may happen that if you do a couple of changes in your object, there will be a point if you change something, your construction will crash, which is a problem, the so-called topo naming problem. So it is usually better not to construct on any of these planes, but to construct on a plane that is somehow relative to the origin of the object. I'm not gonna do this for this here. I'm gonna go the wrong way, because the wrong way is the more easy way, and for an object that is not made of 100 steps, it's usually not a big deal. So what are we going to do? On the upper side of the clamp we need a sort of a tooth that's gonna hold a different plate in place, and therefore we're gonna click this surface, this plane, and we're gonna start a new sketch on this plane. We now see our whole object, and unfortunately my screen has changed and I have to drag back my toolbars. We start to draw a rectangle again, and this rectangle should be here at the end of our clamp. Well, the question is, how do we get it to be exactly ruled to these? Moving it visually makes no sense. We have no points, we can't select anything here. So what we need is, we need so-called external geometry. We have a couple of functions here, and one of that is this blue box with the bar. Once you switch to it, you can see this new symbol, and when that symbol is active, you can see that you can select geometry from the previous sketch. And that's the next problem which you should be aware of. If you can see the object you created before, the pad, you will select the pad itself. And the problem is that in this case also it may happen that you get problems later on if something changes in this pad. So what I'm going to do is, again, something simple but not the best way to do it. I'm going to select this external geometry. If I select these two lines, it gives me these 2 points. That's what we need. We don't need anything more. So just keep in mind, for later designs it makes sense to learn about techniques that are better than selecting any vertices, any lines that have been derived from the previous feature. This pad is called a feature. So as we have these 2 points now, we can carry on and just constrain these over each other, and we need one constraint, which is a length, and that length is 10 millimeters. So if we look to our tasks, we can see we already selected all needed constraints. We can close it, and again we can pad it. So this time we're going to pad it 2.5 millimeters, and normally this would be everything we need. I want to make it a little bit nicer. I select this line and I'm going to create a chamfer, which is going to be 2 millimeters to make it a little bit slanted. So that is all I need for my little design. I'm going to save it again. And now comes the point, how do I get this to be a 3D printable part? So first I'm going to switch off the sketch I selected before. I select the feature containing my design, and I'm going to switch to a different workbench. And the workbench we're going to use is the Mesh Design workbench. In other tutorials or in wiki pages, especially from the former 0.16 versions, you may see export to STL file. I do not recommend this because you don't have as much control over it, and I have the experience that in many cases I get a invalid STL file when I just export my whole model. So I stick to selecting what I want to export, go to meshes, click create mesh from shape, use the standard meshing mode with these two standard values, a surface deviation of 0.10 millimeters and an angular deviation of 30 degrees. I'm going to select OK. And now I can switch off my 3D model, and what stays is my printable model. The difference can easily be seen if we go to the wireframe mode. As you may know, STL 3D printable wireframes are made of triangles, and we can see these triangles here. If we flip and look to the 3D object, that one is made of orthogonal construction lines. So switch back to our object, set view mode back to standard mode, and now we select it again and use the right mouse click and say export mesh. Now I can export this mesh to a file, call it clamp, and we are more or less done. We're just gonna do something. So I opened the file in an STL viewer, and we can see, well, it just looks like any model from Thingiverse. So that is basically everything you need to know for your first simple objects to create them in FreeCAD. Just keep in mind the way I've done it here is a very basic way, and once you start to create more complex things which I'm gonna show you in different videos, then you should learn to use different techniques. If you like to see them, just look to my other videos that I've already created showing advanced techniques. This one was for the very early beginner. Thank you for watching. Have fun.